Fred Staub for Cruise Control. McLaren's design director Frank Stephenson continues his walk around of the brand new McLaren MP4-12C supercar.
As you see inside, it's very simple, an iPodish sort of approach in that we've tried to eliminate most of the buttons on the interior, and we've incorporated those buttons that are necessary into the touch-sensitive screen on the console. So basically anything you need to activate is located on that touch-sensitive control. Very visible and very easy to reach with your hand, and only the basic information that you need in different modes is on the instrumentation table. What we have mainly, of course, is the tachometer, the gear that you're in, and the speed that you're doing. Anything else that's necessary is a call-up option. And as you see on the steering wheel, we have no buttons on the steering wheel. There's no need to have buttons there. You're only occupied with the shift paddles, which are Formula One influenced in that they are pivoted from the central part, and they move with the steering wheel. The reason why we've actually eliminated all the buttons from the steering wheel is because as you're driving a car like this, you don't want to be distracted, disturbed with too much information. In a race car, it's normal. It's the office of the racing driver, and they need to operate quickly, all kinds of optional management possibilities, handling and dynamics. We've done that also, but we've located it on the center console and through, like I said earlier, the actual screen, all the information that you would ever need to have at your fingertips. As we walk around the car, you'll see that one of the more dramatic parts of the design is actually this intake area here. That has a couple of reasons. We've tried to make the car have as small a footprint as possible. The advantage of a small footprint actually is that you can manage the car much more easily. It's not as dominating to you as a wider car would tend to be. We've tried to centralize the mass, so we bring everything into the middle of the car for better handling. That meant that the main radiators on the side would optimally be placed inboard and in car line, meaning that they're not really in the flow of the wind. It's a bit contradictory because you would expect the radiators in a car of this performance level to be face on with the wind, but in effect it's much better for us on this car to optimize the handling, and we've generated a shape that actually is in car line. The radiator is pretty much this direction here. That raises a challenge to the engineers, the designers, to actually how do you get the air in. So more than just a styling feature, this wing here, it's been computer generated, and what it does is effectively turn the wind as it goes past very efficiently into the radiator, so you get a full force impact of the wind, of the air needed by the engine to come in through the radiator in that area there. A few more intakes. All this air that is actually going into the car has to come out. It's a physical requirement. What we do here is basically try to help the air to escape the hot area of the engine bay, and we basically riddled the back with holes, very calculated areas, but that all efficiently helps the evacuation of heat from the engine bay. A lot of it is also for heat soak, which is when you're at an idle and you want to actually not overheat the engine. A lot of the air can just simply escape through this area here, which is one of the extremely hot areas of the engine. The engine, sorry to say, you can't really see a lot of it because it's so low. That's one of the other challenges we had, was to lower the center of mass, keep all the weight as low as possible for optimization of the handling. That created an extremely low engine, and that is for handling characteristics the way to go, obviously. Another one of the handling characteristics that we've tried to optimize is actually the actual planting of the car on the road. We have what's called an air brake. It's not a spoiler. We don't need this to be activated to achieve Vmax or maximum velocity, maximum speed. It's an air brake, sort of in the same principles as an airplane. When you need to apply the brakes urgently or in times of heavy braking, whatever, what happens is the hydraulics of the clutch will activate it, and as soon as it's activated, the wind takes over and continues to push it up. So you'll have pretty much a vertical wing in the back that helps to concentrate the weight transfer so that the back end stays low, stays glued to the ground. That helps us also in the sense that we can lighten all the materials needed to actually work with the wing in that process there. We have what's called the CHMSL, the center high-mounted stop lamp. Probably the biggest one in the industry, I'd say, simply because when it is activated in its full function of a vertical spoiler air brake, then we still need it to be legal, so that brake lamp, Chimsel, extends further down into there. It's very, very effective. Another curious feature on the car, purely based on engineering, are the exhaust pipes, the double exhaust pipes we have in the back. They're cam coated here. This is basically a finisher, and the exhaust pipes are located within that finisher. They're here. Basically, this is required here to keep the heat from coming up at an idle and toasting the rear of the car. So very, very effective. Two advantages of locating the exhaust pipe here. It's legal, of course, but the advantages are that we can shorten the route of the exhaust pipes that normally come out from underneath the car. As I said earlier, weight is an extreme obsession by McLaren. We were searching for the shortest way out of the engine, so that was directly straight out the back. And another very important factor is that we can actually optimize the aerodynamics. If you locate the exhaust pipes down below where we normally find them, then you're kind of ruining the flow of air underneath the car. We tried to keep it basically as simple, as pure as we could, and that meant the complete relocation of the exhaust pipe. So we brought that up into this area here, optimizes the complete aerodynamic package. Another interesting thing on the back of the car, of course, are the taillights, or the lack of taillights, as you might think. They're located at the very top. There are these two bands here. The top one is your indicator, and the second one is your brake and your normal running lamp. And the other ones basically are just dividers of the air coming out through the rear. In this case here, the issue, of course, that you're legally required to have reflectors, you're legally required to have a fog lamp in the back, and a reverse tail lamp. Normal process, of course, is to sort of clutter up the rear end, tack them on somewhere. We've reached even that detail of how do we actually optimize the location of all these parts. If you look closely down here, you'll see sort of a hockey puck shape here. That's your reflector, so it's integrated cleanly into the design, works perfectly. And more towards the center of the car, we'll have the reverse lamp, which is white when it's on. When you do turn it on as a fog lamp, this will go deep red. So we have an optimization of the lights in that area. This here is the rear view camera. We have one in the front, inside the car, between the driver and the passenger, that gives you sort of a wide angle view of the track in front of you, and one out the back that assists you in looking backwards for parking purposes, or just to record the track day and see who you're pulling away from. That's about it on the back of the car. I think the reason for the design, you can obviously see it's been completely influenced by aerodynamics and just a bit of finessing to the design to give it its purposeful look. We're not trying to make a car that is extravagant and just a styled feature. It's more or less controlled by engineering and just a bit of fine tuning to make the car as aesthetically pleasing as we could. I think that probably is the secret to making a timeless design. We don't style animals, we don't change animals from year to year. Basically, they've been evolutionized over hundreds of thousands of years, and they've reached optimal shapes through the optimization of their performances requirements. And that's basically what we're trying to do here, is not add and more take away than anything else. So we hopefully can expect this car to live on quite a few years without any modifications at all. We've optimized it, and we've come out with a product that we're extremely proud of. I think the car is going to do very good in its market segment, and more than just compete, I think it should be leading the way for all future supercars in the segment.